Every time an object is instantiated from a class, a constructor is executed. A constructor is very much like a method, but it has some special characteristics. You can spot one because it always has the same name as the class, and it has no return type specified. And constructors can be overloaded, just as you can declare lots of methods with the same name, as long as they have different argument types being passed to them. You can declare lots of constructors the same way. Two different ways of constructing a class named circle demonstrate what I mean. One specifies the radius of the circle, and the other lets the radius value default. The constructor, without any values passed to it, is special. It's known as the default constructor. Every class has at least one constructor. If you define a class without defining a constructor for it, one is inserted by the compiler. Now, the one that's inserted is the default constructor. It's not called that because it's automatically inserted. It's called that because it has no arguments and all the internal values are simply allowed to default. This is a default constructor of a class named circle. You can write one this way, or you can let the compiler insert it for you. Either way, there is some other code inserted into the constructor. If you had to write it all yourself, it would look something like this. The return statement returns a reference address of the current object. Now, you never write it this way. In fact, the compiler won't let you, but that return is always there. Every constructor returns the address of the object that is being constructed. The this variable is present inside the constructor and can be used. It's just that you can't code the return statement for it. The call to super shown here is a call to the default constructor of the superclass of this class. It's always there as the first line of code in every constructor. You can write it, or you can let the compiler stick it in, but a call to super is always present. Any code that you include in the constructor will come after the super call, whether the super call is automatically generated or whether you write it yourself. Here is an example of the default constructor being used to set the radius. You never see the return statement in a constructor code, but you may see the call to super. The only reason that you would ever want to code your own call to the superclass is if you wanted to call some constructor of the superclass other than the default constructor. Here you see a constructor with an explicit call to a superclass constructor that requires a descriptive string as the argument. You cannot create an object without calling a constructor, and the constructor always calls a constructor of its superclass. If the inheritance chain is 5 classes deep, then 5 constructors are called every time you create an object. But not every class has a default constructor. Let's say you write a class with one constructor, and that constructor requires an argument. This class has no default constructor. The only way to create an object of this class is to call this constructor and specify the value of the radius. That is, since you supplied a constructor, whether or not it was the default constructor that you supplied, the compiler did not insert a default constructor for you. If you extend this class, you will have to allow for it this way. This is the default constructor of a class that extends the circle class and sets the default radius to 5. You must include a call to the constructor of the superclass because the superclass does not have a default constructor, even though this is the default constructor of the subclass. If you decide, or if you're required to put in your own call to the constructor of the superclass, then the call must be the first line of code in your constructor. You can't call it from some other place in the constructor. You can't call it from any other method of the class. You only get one shot at the superclass's constructor. You can let the access permissions on a constructor default, and it defaults to package. This means that any other class of the same package can create an instance of this object by calling its constructor. If you want to allow anybody to be able to create an instance of the object with this constructor, you can declare it as public. This is the way you would do it if you were building a library of classes to be called by all users. Now here's a special one. This constructor can only be used by subclasses of this class. It's not available from outside. You cannot create an instance of this object except by extending it to another object and using super to call its constructor. Of course, with overloading, you could have other constructors that allow access, but this one can't be used except inside this class and by calling super from a subclass. This one is even more restrictive. This one can only be called from inside the class. It can't even be used by calling super from a subclass. If this is the only constructor in a class, or if all the constructors are this restrictive, you cannot create an instance of the class. Well, there is one way. Classes that do this generally provide a method that you can call to get a copy of it. It has a static method that has a new statement in it that creates and returns an instance of itself. Now, this sort of thing has its reasons. For example, the Java util currency class has no public constructors. To get an object, you call one of its static getInstance methods, and you'll get one returned to you, but there is never more than one instance of the class for any one currency. Your return may be a new object, or it may be the address of one that already exists.